Hello Year 9, you've uploaded some brilliant work over the last week on energy transfers and efficiency, some really good calculations, some really good answers. Really pleased. This week we're going to go on and do some exam questions as your remote learning, but I want to do the first little activity here to begin with. Okay, so you can need a pencil, you can need something to write on, it could be a pen, it could be a whiteboard, whatever. Something to write on. You're going to be annotating a diagram, so you can be writing notes, you can be adding information to a couple of pictures. Okay, it's going to be on energy transfers and efficiency. So what you need to do is pause the video and find that pen and pencil and pencil to write with, and you need to find a 5-minute or about 5-minute song that you're going to use as a timer, okay, to help you not spend 5 hours trying to annotate a diagram. You're going to spend 5 minutes. Okay, so use a nice song as a timer, 5 minutes or so, just to do that. So find a song, get your pen and paper ready, and pause the video here until you've got that done. Okay, so you've got your song, you've got your pen and paper. Get ready to start the song. I'm going to put the pictures up. Okay, I'm going to talk for a couple of seconds and I'll tell you when to start off. Okay, so the pictures are about a kettle, an electric kettle. I've got this type of graph here. Okay, I want you to annotate around this graph. What is this telling us? What's it showing? What's maybe going in? What's coming out? Okay, what might be going in the kettle? What's happening in the kettle? So annotate the diagram, put in some numbers maybe calculating efficiency, okay, about this thing. Okay, so play your video and pause this one, and you've got like 5 minutes. Go. Okay, so hopefully you enjoyed your song and you have finished your annotations. Here are some of the things that I put around the pictures. Okay, so you can compare your work to mine. So I've made up some numbers. I put 1,000 joules of electrical energy going in, 800 joules of useful energy coming out, 200 joules of wasted heat energy coming out. Okay, because I've got this Sankey diagram, it's 10 squares wide. So I can make up a scale for that. You might have made up a different scale. You might have said 100 joules going in, a tiny little kettle. Or you might have said it's the staff earn to make their tea at break time and lunchtime. It could be 10,000 joules of electricity energy going in. Okay, but it is 800 joules of useful heat. But be careful here, it's 200 joules of wasted heat. The wasted energy in a kettle is heat, okay? When you boil the kettle, steam comes out the top, and that's wasted. That goes off into the surroundings. It's wasted energy to the surroundings as heat, okay? There'll be a tiny fraction, a slither of this arrow might be sound, but it is so much smaller than heat, then you can pretty much ignore it, okay? Now, I've done a calculation here. I've done my useful energy, 800, divided by my total energy, my total electrical energy 1,000, 800 divided by 1,000 to give you 0.8 or 80%. Now you might have different numbers for the electrical energy and the useful energy. You might have different numbers. You might have 100, you might have 10, you might have 1. Okay, so you might have 10 and 8, you might have 1 and 0.8, you might have different scale. But your efficiency calculation, it should still give you 80% or 0.8. Okay, and then I just put some stuff around here. So most energy lost leaves the kettle as steam, electrical energy is going in, useful is still in the heat and the water. So the energy that's still inside in the hot water is the useful energy. Okay, you might put some more information here. Take a picture of this and you can upload that with your exam question answers that I'm going to go talk about in a second. First one, we'll have a couple of looks at some of the work that you've uploaded. So this is a wonderful example of good workings out. It's really important you get into the habit and you form that habit as early as possible to show all your working out in a calculation. It will help you get marks in your exam. Okay, this is a perfect example here. Even if you, and whoever the student is got this wrong, that's right, if they got this wrong, they still probably get a mark just for writing 25 plus 75. Just for writing down how to find that total energy. Okay, writing down what you know is a really, really, really good technique. It helps you form the ideas in your head. It keeps the flow of the answer quite coherent and clear for the examiner to give you marks. Really good habit to get into showing all of your workings out. Okay, so keep doing that. The next thing, Sankey diagrams. Have a look at these two Sankey diagrams. The big red circle is a bit of a clue. Which one do you think is wrong, but why? What's the problem with this Sankey diagram? Okay, how is it different from the other one? Okay, now if you look at this, this Sankey diagram, we've got this thickness here, the total energy going in, and it's the same as the total energy coming out. But we've somehow magically created this extra bit of energy, and that breaks a really important law, the most important rule, the most important law in physics that you've learned so far. Okay, I want you to say it out loud in 3 seconds. 3, 2, 1. The conservation of energy. Okay, if it breaks the conservation of energy, it doesn't work. It's wrong. Okay, you cannot break that law. It's the law. Okay, this one on the left, this one, it's got this extra red thickness here. I coloured it differently, just to show you, just to highlight that. But this total thickness here is the same as the total thickness after it's split up. Okay, so when I look at this Sankey diagram, you need to be careful because you've got the numbers perfect, but you just need to be careful of the sketch. Okay, you want that not to look like this, to look like this. Okay, now it might be just because this top one's kind of curved down a little bit. Try and keep along that line, it will be a little bit clearer. So for here, I'd expect this top arrow, the useful, okay, to be 2 lines thick, maybe. Okay, 2 lines thick. And this bottom one to be a single line thick. Okay, so just be careful when you're sketching the Sankey diagrams. And STEWART. Next, 2 wonderful examples of 6-mark question answers. Okay, but I just want to highlight the thing. These will both get 6 marks. They both get the same number of marks. Okay, this one will take a lot quicker to write than this one. Okay, so if you're making pages and pages of writing for a 6-mark question, that's fine. You've shown really good knowledge. It's excellent, and don't try it. It's not a bad thing, but when you're in your exam conditions, when you're doing your 6-mark answers, try and be as concise as possible. Try and really write the important information. The examiner's looking for key parts to those questions. We're going to be doing lots of 6-mark exam practice over the next couple of years, but just wanted to highlight that you don't have to write lines and lines and lines and lines and lines and lines and lines of text to get a really good mark. Diagrams, a lot of the time, can be really helpful when you're writing those 6-mark questions. Okay, right. This week, we're going to send this link out through ClassCharts. We've got 4 questions on efficiency. The mark scheme is attached, so what you want to do, get a piece of paper, or you can do it online if you want, however it works. Give the questions a go, check the answers, give yourself a mark, and then take a screenshot, take a photo of what you've done it on, and upload that to ClassCharts to show your teachers that you've done. You don't need to take a picture of all the work if that's difficult, so you maybe just take a picture of the score at the end, and you maybe one example of the questions that you've done if it's taking up lots of space. But give the questions a go, give them a mark. Okay, I hope everyone is doing really well at home. Take care of each other, take care of your family, and I'll hopefully see you soon. Bye bye.